Hello everyone, I'm Caleb and welcome to Wattage Wisdom, where we believe that anyone with the motivation and internet access can become an expert in any field they desire. In this video, we'll be going over artificial intelligence, and the hope is that by the end you'll have a basic understanding of some popular types of AI and how they work. This video will primarily focus on neural networks, and as you will see, are one of the most popular and widely used types of artificial intelligence. These concepts may seem a little daunting to start, and you may not understand everything your first time through, but please know that as you continue to review and learn more about these systems, you will soon find yourself understanding things that you previously thought were incomprehensible. So please, hit the like and subscribe button, and without further ado, let's get into it. Oftentimes you hear words like artificial intelligence, machine learning, and neural networks used interchangeably. However, each of these terms are somewhat different in what they relate to. You can think of artificial intelligence, or AI, as the general and broad category that encompasses a variety of disciplines where a computer completes tasks that are normally done by humans, as they require human intelligence and discernment. So basically, if a computer or robot is doing a task we associate with human intelligence, then we would categorize that as AI. Now, within the scope of artificial intelligence, we have a branch known as machine learning. This type of AI focuses on the use of data and algorithms to imitate the way that humans learn so it can gradually improve its accuracy. The goal of machine learning is to develop systems that are accurate in predicting outcomes without being explicitly programmed to do so. One of the ways we achieve this goal is through the use of deep learning, which utilizes an artificial neural network with multiple processing layers that aim to extract different features from the data. These neural networks are designed to help computers process information in a way similar to the human brain, hence the name neural network. Although you may not be familiar with the workings of a neural network yet, I'm sure you are familiar with applications that rely on this structure. For example, the ever-popular ChatGPT is based on a neural network and is designed to process and generate responses for a sequence of characters that make sense. Self-driving cars also rely on neural networks for things like visual recognition so that they may process the world and objects around them. And I'm sure you've all relied on a virtual assistant before, like Alexa, Siri, or Google. All of these assistants use neural networks, so each time you interact with them, they can learn more about you, your voice, and accent, so that they may strive to emulate a more human-like interaction experience. Of course, these are just a few areas that rely on neural networks, and there are thousands more applications which continue to rely on this technology every day. With these wide-ranging applications of neural networks, this video, as well as the subsequent ones, will focus primarily on deep learning and the use of neural networks to create artificially intelligent systems. And while most of my examples will be centered around vision and object recognition, the building blocks I will be explaining can be applied to any deep learning application like text analyzers, video, speech processing, large data sets, etc. Essentially, you are only limited by your imagination when deciding where and how you want to apply the power of neural networks. As we just talked about, machine learning is the process by which computers can learn from data without being explicitly programmed to do so. So opposed to traditional computer programming seen in the top left, where you give the computer a set of rules and input data and the computer acts on that data, machine learning, as we can see in the top right here, kind of flips that script. So here we give the computer a set of input data and answers, and then machine learning will generate a set of rules, meaning it learns from this training data and can teach itself to recognize patterns. It does all of this through a neural network. A neural network is essentially a series of nodes or computational units which model the human brain and nervous system. These nodes, seen here as like the little green dots, can also be thought of as neurons, which are inside the hidden layers. These neurons are connected through a set of inputs and outputs. And you can see that as the inputs come into this network, there are computations performed on them by the neurons, which are going to hold different weights and biases. And then depending on their learned values, they can give rise to various outputs. When a neural network learns, it automatically adjusts the weights and biases of these green nodes so that it can give the correct output for a specified input. We'll explain more how this neural network learns through the training process on the next slide. A neural network learns through minimizing the cost function. This means for each training example, there's a specified cost per example, which is the difference between the network's predicted output value and what the actual output should be. You can think of this in a simplified way as basically the error between the guess and what the actual right answer is. This cost per example is then averaged throughout all the examples, and from there, a negative gradient of the loss function is going to be found. So as you may know from vector calculus, or maybe not, the gradient is the direction in which the slope has the greatest increase. Or if the words vector calculus just sound a little scary to you, don't worry, it's rather simple. Say you were standing on a hill, the gradient would be the direction in which the hill would be increasing the steepest. Therefore, the negative gradient is the direction in which the slope has the greatest decrease, or the steepest downward descent. So as a neural network is trying to minimize this cost function, it's going to continually nudge itself in the direction of the negative gradient so that it may converge near a local minimum of the cost function. This entire process is known as gradient descent. You can think of this process almost like a ball rolling down a hill, where the network will continually nudge itself through updating its neurons' weights and biases so that it can approach a local minimum of the cost function, which is going to be seen here as the dark blue areas of the graph on the top. In order to find out which direction to nudge these weights and biases, the network will utilize this negative gradient descent as it indicates which way the neurons must be nudged. Then, the network will continue to backpropagate these updates through each layer in the network, adjusting the values inside the neurons so that the next time they perform computations on the data, they can output an estimation that's closer to the actual output. This update process will happen after each batch is processed, so multiple times throughout your network training process. And the specific way in which these weights and biases are going to update is dependent upon your chosen optimizer, learning rate, and a few other parameters that I will cover in future videos. So that's a basic overview of what machine learning is, how it fits into the realm of artificial intelligence, and how it can utilize deep learning through the use of neural network. Now, before I let you go, I want to run you through some steps that you can take if you're looking to become an AI developer. The first is to take a deep breath and relax. Don't let the complexity of artificial intelligence or any of the concepts I explained in this video overwhelm you. Know that you have the capacity to understand and excel in the world of artificial intelligence so long as you put your mind to it. And of course, I'll be here to help guide you through your journey into this exciting world. So please continue watching these videos where I'll walk you through step by step how to build, test, and implement your model, all while providing you with helpful sample code and considerations that can help you get started. Another thing I would recommend is conducting your own research. Maybe your interests extend beyond what I'm going to cover in my videos, or you want to supplement these videos with additional material. The world of artificial intelligence and machine learning is also constantly developing, with new groundbreaking discoveries being made every day. So please, conduct your own research, and who knows, soon you can start making your own explanatory videos and even teach me a thing or two. Lastly, there's no better way to learn than trying it out for yourself. Through the use of TensorFlow and Google Colab, you can develop your own artificial intelligent neural networks with nothing more than internet connection, which I'm assuming you have since you're already here. So make sure to check out tensorflow.org and also familiarize yourself with Google Colab, as my future development videos will focus on utilizing these helpful tools to create our own fast, efficient, and reliable artificially intelligent neural network models. As always, thanks for tuning in. In the next video, we'll go over how you can develop your own artificially intelligent neural network. So don't forget to like and subscribe so we can keep providing you with awesome content. If you have any questions, topic suggestions for future videos, or you maybe want to collaborate and create some videos of your own that'll be featured on this channel, please reach out through email at wattage.wisdom@gmail.com. Lastly, don't forget that with the motivation and internet access, you have the power to become an expert in any field you desire.